Hey everyone, here is my video explaining my approach for the combined cycle power plant problem. The first question for the problem is, for the problem described in the project topic section, determine what type of machine learning approach is needed and select an appropriate metric to evaluate performance in accomplishing the task. So for my approach, first, to provide context on the combined cycle power plant problem, we are trying to predict net hourly electrical energy output, and we are given four variables, which are temperature, ambient pressure, relative humidity, and exhaust vacuum. Now, to solving the problem, as mentioned earlier in the course, one of the first ML approaches we should use to check for variable relationship would be a simple regression. So I will be creating a regression via the Excel method and be looking at two different output metrics, adjusted R squared and standard error. So why adjusted R squared instead of the regular R squared? When dealing with multiple independent variables, such as this example where we have four, adjusted R squared is often preferred as it penalizes the inclusion of unnecessary variables, providing a more realistic measure of model fit. So now for the second question, it reads, determine which possible features we may want to use in the model and identify different algorithms we might consider. So for this problem, we can utilize different methods such as lasso and ridge, which affect the absolute value of the feature coefficients. And in the case of lasso, it can effectively perform feature selection since it can shrink coefficients to zero if it feels it's a non-important feature. However, for this exercise, I haven't utilized any of these methods, but instead did random feature selection and an example of full feature inclusion to see the different results. Now, for the next question, it is asking to create a training test set and a validation strategy. So moving forward to the Excel analysis, you can see at the bottom four different tabs. So the first two tabs show the training and test sets when keeping all four features, and while the last two tabs show the training test sets when keeping only the exhaust vacuum and ambient pressure features. I manually kept 90% of the data in both scenarios for training, while 10% for testing. And you can see here on this tab, there are about 8,570 observations out of the about 10,000 that we had in the original set. And then in the test set, we have about 1,000 here. And the difference between the 90 and 10 splits across both scenarios is that I chose the last 1,000 rows for the test in the first scenario, while choosing the first 1,000 rows for testing in the second scenario. And now coming to the fourth question, I decided to test regression on both these scenarios, with the main difference being the combination of features chosen. So now after running the regression, and if we go here, we use the training data set and then to get the results for the test, I am concluding that keeping all four features help predict the new hourly electrical energy output the best. And now I want to go to the specific output metrics in the test tabs for both scenarios. So if we look at the first scenario, I noticed that the adjusted I put a personal threshold that the adjusted R squared should be more than 0.9 to accurately explain most of the variability in the PE variable. And in this scenario where we included all the features, we see that the adjusted R is 0.929, which is above my threshold. And additionally, looking at the standard error as well right below it, you can see that it's a very negligible 4.52, which in my mind is acceptable to explain the PE variability. And now if we look at the second scenario where we only included the V and AP variables, you can see that the adjusted R has dipped a bit here to 0.789, which is below the threshold that I had said before of the 0.9. So a majority of the variance in PE may not be explained, utilizing these features in the model. And then additionally, the standard error has also increased to 7.79, which is not ideal. So from this, my conclusion is that keeping all the four variables to explain the PE and predict the PE is probably the best scenario in for this problem. Thank you.